Hey guys, this is Subash working with Dr. Lu on covert communication research projects, and this is one project where we have implemented steganography in peer systems using like we have implemented this application, like implementing this kind of steganography in peer systems using social media, that's especially in the Skype. So like before coming to know how we have implemented the kind of steganography or the VoIP steganography in Skype, let us see some what Skype is. Like Skype is an hierarchical, it's a peer-to-peer network with a single centralized element, that's a login server, and that is found by two types of nodes, like ordinary nodes and the super nodes. Super nodes would help finding the people in the network, and ordinary nodes are like they start and stop the call, like from the starting and receive the call and send the messages. Like you can see here in this picture how the Skype working mechanism is, where the bigger nodes, the one big large node shows the Skype login server, and that is where the messages get exchanged between the internal nodes and the main Skype login server node. And the other small nodes are like the the ordinary host and the super nodes. Like in the existing system, like a paper from Vijayan and Mazurek, they have introduced a Skype hiding mechanism in the VoIP by providing the means for the covert communication, where they have encrypted the Skype packets. The data, like they have taken the Skype packets in the network between the sender and the receiver, and they have embedded the data within it. And one important feature of the Skype that makes us allow to implement the VoIP steganography here is Skype does not use any silent suppression mechanism. That means if the sender and the receiver are not talking anything, then the silence packets would still go or be shared between the people, between the sender and the receiver, and that is when you can make use of those silence packets to embed your secret information in transmission from sender to receiver. So in this proposed method, we wanted to prove the undetectability of having dynamically embedding the secret data onto the carrier VoIP network, which is voice over internet protocol packets. And this dynamicity means the secret data is embedded into the packet with the position designed by the algorithm, so that the silence packets, though they are being though if they are ever being watched by an intruder, because of this dynamic way of embedding the packets with the respective position that is being populated dynamically when the sender and the receiver starts the communication, the intruder will not able to find a proper pattern of finding the packets that are the silence packets containing the information. And here we use JPCAP, which actually captures all the packets from the network internet card reader, and we embed the secret message into the payload of those JPCAP captured Skype packets, which is of nearly 100 to 700 bytes as per our user defined protocol, and we are getting the destination port and the IP address from the Skype packet header, which is how you need to identify your destination. And in this dynamic methods, we have the actual Skype packets would be of 700 to 800 bytes, but the silence packets would be of size 100 to 200. So from that, like every 11th packet as per our algorithm, which can be changed as per the time of deploying this application, we are embedding this secret information into those silence packets, and those silence packets can then be broken into small chunks and send it across the network. Yes, if you take a UDP packet, this is the place where we embed the data in the UDP packet of the data position, which already has the source and the destination port and the in their headers. So that is where the UDP packet is surrounded by an RTP control packet, which actually has a timestamp and a sequence number, and it also contains the payload message. So it is using this sequence number at the receiver, we collect the information from these RTP packets and again reunite all these messages, the data chunks, to form a meaningful message that is sent by the sender across the network. So where exactly we are hiding the information? Like if you take an IP header and then there is an UDP header, then there is an RTP packet. So your UDP packet, which is embedding the message, is again covered up by an RTP packet and then by the IP header, so that the message is being hidden in all this layer of structured RTP packet. So in the actual implementation of the Skype, the VoIP steganography, we have initially the sender and the receiver, the Java client application, which tries to access the individual Skype accounts of two users and loads up all their contacts. After this Java client application loads up all the contacts that are available at the Skype level, it will start sending the synchronization messages between the sender and the receiver, and once the synchronization happens, that is when the actual messages can be transferred. So even at the receiver, the receiver should wait for the initial synchronization message to happen, and that is when it should start the communication. So if you look at the pictorial representation of the working model, you can see the client, and then the client is having his own Skype client, and client 2 has his own Skype client. So it is where across these two Skype clients there is a Skype server, which I have already shown you as the server login node, which stays there, and the super nodes that comes in for the transmission, which comes into role, that sends the information across the sender and the receiver. So if you see this, like this is a Java client application that looks like this, which has an UI, user interface, where you can see the list of the friends that can be refreshed every time whenever a new person has joined in your Skype account, so that it would list all your friends. And then there's a status bar, there's a chat window, and then you can click on this send. So this is the client 1. So this is at the client 2, where he is still waiting for the Skype friends to be loaded. And once the Skype friends were loaded, like you start your Skype application, you start your VoIP steganography Skype application at the same time, and then when you click on refresh, that is when this Java application tries to contact your Skype application and loads up all the friends details. So once it loads up all the friends details, you can click any of the friend. For example, Facebook, Vineet 5555. Here, if you click on Vineet, and if you click on Vineet and you click on like for example Subash, if you click on that and you click on call, a call button which is right here, and then that is when you can see Subash Kumar calling. That means this is something like another person is calling Subash. So if this is you're receiving a call, just like in your Skype application. So once you accept the call, you can see the status as the call status is in progress, and once the status changes to in progress, initially the two Java client applications that we have developed tries to get connected, and then once they are connected, the application, the algorithm that we have developed, sends the synchronization packets between the sender and the receiver, which will make sure that the two sender and the receiver are in a synchronization, and it's only after that the messages will be shared. So now that you can see the status as the synchronized, yes, once they are synchronized, you can see the status has been changed from previously in progress to received calling status. That means you can receive the call. So once you can receive the call and both the sender and the receiver are just so silent, and or even at times, like even if they are talking, like there will be some silence packets that will be transmitting from the sender to the receiver, and that is when you can type in your message in the lower box here, and you can click on the send. So once you type it here and click on the send, then you can see the message, hi, this is a secret message from system 1. That means that from the client 1 we have sent the machine, we have sent the information, we have sent the message to the receiver. So that is how the messages are being transmitted from system 1 to system 2, like the client 1 to client 2. So you can see the message which we have received from the other client. By making use Like these two individual Java applications, the client interfaces are no way connected to each other. They are running on two different laptops, but they got connected only through the Skype interface. That means the Skype packets are taking this message from one system to another system. So this is how we have implemented the VoIP steganography in Skype packets, which are used as a data here, which are used as data hidden carriers. And thank you for listening to this.